Welcome to solverfy.
Hello everyone, in this problem we have to replace the force on the frame via equivalent resultant force. So we require to calculate equivalent resultant force, and we have to calculate moment of forces about the point A. Now see here, consider this force to be F1, this is F2, and this force F3 of 400 Newton. We will find x and y component of these forces. You can extend this force in this direction. So this having x component here, y component in this direction, and this angle is 30 degree. So F1 force we can write F1 force having x component 300 cos of 30 I cap and y component 300 sin of 30 j cap. When we substitute the value of cos 30 and sin 30, your answer will be 260 I cap minus 150 j cap Newton. Excuse me please. Now F2 force. This we are considering F2 force. It is along the x-axis. So it could be written as 500 I cap Newton. This is F2. Now F3 is along negative y-axis. So this can be written as minus 400 Newton j cap. So it will be negative j cap. I am writing first, then we will write the unit. So this is third. So resultant force on the frame will be vector addition of F1 plus F2 plus F3. Now substitute the value of F1, F2 and F3. You will get the resultant force on the frame. The resultant force on the frame I am writing here. F1 is 260 I cap minus 150 Newton j cap plus F2 500 I cap and F3 is minus 400 j cap Newton. So finally the result will be 760 Newton I cap minus 550 Newton j cap. Here I am writing the unit. Now you can draw the diagram of this resultant force. This is your x-axis, negative y-axis. This would be the resultant force. You can find the magnitude of resultant force and direction. The magnitude of resultant force will be x component square 760 plus y component square minus 550, square root of it. So this value will be 938 Newton, and you can give the direction by measuring angle theta as shown in the figure. This will be tan inverse of 550 divided by 760. So this angle is around 35.9 degree. So this is the answer for resultant force on the frame. Now we will calculate moment of forces about the A point. Since if we consider the F1 force is acting at P point, F2 force is acting at Q point, and F3 force is acting on R point. So by following this diagram, you can write the moment of force about the point A, AP vector cross F1 force, AQ vector cross F2 force, AR vector cross F3 force. Now, from the figure, you can write the AP vector. AP vector is minus 0.5 j cap meter, and F1 we have already calculated 260 Newton I cap minus 150 Newton j cap. Now, value of AQ is minus 1.5 j cap and F2 force is 500 I cap plus AR vector is 0.5 I cap minus 1.5 j cap and F3 force is minus 400 j cap. On simplifying, we will get 0.5 into, you have to take the cross product and simplify it, then it will be 0.560 k cap plus 1.5 into 500 k cap minus 0.5 into 400 k cap. So on simplifying, this becomes 130 Newton meter k cap, 750 Newton meter k cap minus 200 Newton meter k cap. So the final answer for moment of force about A would be 680 Newton into meter k cap, or we can also write 680 Newton into meter in anti-clockwise direction. So this is the final answer for moment of force on the frame about the point A. This is the answer. Thank you for watching.